today we are taking a video on Kaplan Turbine. Before starting the video, let us introduce ourselves. Myself Ravi S. Mandal.
Myself Ajay Kumar. Myself Kulkarni. Myself VIJAY.
Fifth semester, Department of Mechanical Engineering, GMIT. This video is done under the guidance of Dr.RAJKUMAR.D.G, Professor of GMIT.
Kaplan turbines. Kaplan turbines are suitable for power extraction when water energy is available at low head and high flow rate, which means they are suitable for operation when water is stored in a big reservoir at relatively shallow altitude. In Kaplan turbine, flow is entered through a spiral casing. Decreasing area of casing makes sure that flow is entered through center portion almost at uniform velocity throughout the perimeter. Water, after crossing the guide vanes, passes over the runner. Finally, it leaves through the draft tube. Most important part of Kaplan turbine is its runner.
Cross section of runner blade will have a curved shape when water flow over it. It will induce a lift force due to airfoil effect. Tangential component of lift force will make the runner rotate. This rotation is transferred to a generator for electricity production. Kaplan turbines are axial float machines where absolute velocity of flow is parallel to axis of turbine. Water is precisely made to pass through the runner blades with the help of shroud. Power demand may fluctuate over time. This can meet for varying power demand. Blades of Kaplan turbines are designed to operate under wide range of operating conditions. A rotating blade experiences relative velocity of flow. The fundamental thing in blade design is relative velocity of fluid flow should be at optimum angle of attack at all cross sections, even though absolute velocity is axial.
Relative velocity. Relative velocity will be inclined depending upon blade velocity. Inclination of relative velocity increases as removed from the rotor tip. There should be continuous twist in blade from rotor tip so that at every cross section the angle of attack is optimum. With varying flow condition, relative velocity will be changed drastically. Kaplan turbine blades are adjustable. When flow rate is high, relative velocity of flow will be more axial, so blade should be pitched vertically. If flow rate is low, relative velocity of the flow is more tangential, so blades are pitched in tangential direction. In short, the pitching action of blade makes sure that blade is still in optimum angle of attack. Even under varying flow, apart from controlling the flow rate, guide vanes have got one more function. They help in controlling swirl of flow.
If guide vanes will not present in the flow, would be highly swirling in nature. Such flow will reduce performance of turbine drastically. Due to its poor angle of attack, so guide vanes controls swirling flow of optimum angle of attack. Biggest challenge in the design of Kaplan turbine is how to overcome problem of cavitation, which causes material erosion and vibration. Cavitation is unavoidable in Kaplan turbine since most of the region's pressure goes very low, but damage due to cavitation can reduce by using suitable draft tube which transfer dynamic pressure to static pressure.